Hello everyone, this is Mike and welcome back to the channel. So in today's video, we're going to be continuing on with my PowerShell Build a Script series, and this will be episode 5. So we're going to be looking at how to query a remote computer to find some information about it. So maybe like the operating system that's running on it, the amount of RAM that's there, the amount of processor cores, maybe the free space from the drive, things like that. Things that a help desk person might be interested in knowing about a remote computer should a user maybe call them up for support or something like that. So hey, let me find out some quick facts about this computer and see what's happening. So in order to find out those facts, we're going to be using the repository that is present on that remote computer. So if you've never heard of the repository before, that basically represents an area that's on a Windows operating system that has been there for quite a while. It's been there since the NT4 days and can be used to query information kind of like looking in a registry, if you will. But the difference between it and the registry is the repository is kind of arranged very similar to like .NET in that you could have namespaces, classes, and then instances where something is matching a class. So the instances are kind of exposed to PowerShell as objects, similar to other objects that are produced by commandlets and put into PowerShell's pipeline. So the challenge with the repository is potentially knowing where to go, because there's literally like thousands of different classes that you could query. It's kind of like, if I were to tell you, hey, you can alter this behavior in Excel, you just got to go find the registry key that does it. Well, how would you go about doing that? So some people might search, Microsoft documentation, some might Google it. There's a lot of different ways to kind of figure that out. And once you get experience, like let's say with a particular area, you kind of get to know, like, hey, these are the registry keys that are out there. Well, it's the same thing with the repository. So there's a couple kind of well-known classes that I could go query to find common information that I'm looking for. So now, how do you query that? So you have two different protocols that could access it. One that's on the older side, that's been around since the NT4 days when the repository was first created, and then kind of an updated one that came out around, let's say, the 2008 timeframe. So both protocols query the same repository. So if you're curious where the repository lives, let me switch over to my other view here, and let me bring up just a file explorer real quick here. So if you go into your C drive, go down to Windows, go down to System 32, let me find it here, and then you're looking for a folder called WBEM. So pronounce WebM, WBEM right here. So if I look at that, this whole area kind of is what's considered to be the repository. Right? Now, some people might refer to this as the WMI database as well. That's probably a fair name for it, kind of more a historical name, but again, something you'll find it listed as nonetheless. Okay, so the actual database itself kind of lives in this folder called repository, and you can see what's there. I mean, it's not very big, all right? So it's kind of puny, if you will. But there is a wealth of information here that could be queried if we wanted to, right? So I'm going to bring back up my PowerPoint. Okay, so the protocols to go query this. You have the older protocol WMI, though when I'm using the actual PowerShell commandlets, the kind of referencing of the protocol is going to be DCOM, DCOM. So kind of it's almost like a little family tree, if you will. So WMI is part of DCOM, DCOM's part of RPC ultimately. So that one will be kind of the older historical one, and then SIM, which is actually part of the WSMAN grouping of protocols, is newer. So if you're not familiar with WSMAN, that's what PowerShell remoting uses. Okay, so in this kind of example, I'm kind of assuming that the computers in my, kind of fantasy company I work for here are configured with PowerShell remoting enabled. All right. Now, both of these, WMI and SIM, or their kind of their parent protocols, DCOM and WSMan, they are both not enabled by default on a Windows client computer. So depending on what programs you might be running in your environment, that might be a potential issue. So I'm going to build the script to kind of use either or. Um, but in your environment, you might just have to pick which one will work if either of them will work. So typically, you might see WMI work in companies that already use like a System Center product, like System Center Configuration Manager, or its newer name, Endpoint Configuration Manager. Okay, so that has a SCCM client that runs on the, let's say the Windows 10 computer or whatever the client computer is you're querying, that reports back to your configuration manager server. So it definitely uses the WMI protocol to do that. All right. So now we're going to build this like it's a get commandlet. So you take any of the commandlets that come with Windows here that start with get, like get processor, get process. I'm sorry, get service, get event log. So all of the get commandlets, when you run them, they produce objects as their output, and that's what we're going to do as well. So we're going to be running a couple different queries to get information from a couple different repository classes, and we're going to kind of streamline that output into a single object that's going to be returned back to the pipeline. Now, why am I doing that? Because I want to make this script kind of more universal, right? More standardized, where I can then take those objects and use my other PowerShell commandlets to do whatever I want with them. So if I want to filter, I could use where object. If I want to pick what properties I want to see, I could use select object. If I want to output this data to an HTML report, I can use convert to HTML or export CSV or convert to JSON. So by keeping everything as objects returned back to PowerShell's pipeline, you get the most functionality out of it, believe it or not. Okay, so basically that's what I'm building. I'm building similar to something that would be patterned after a get commandlet. Okay, which if you look at every get commandlet that Microsoft produces, they always return objects back to PowerShell's pipeline. And then you could use other commandlets to then work with those objects. If you want an HTML report, if you want CSV output, if you want to, I don't know, do whatever with it. Right? And we will build in support for pipeline and multiple values on the parameter, so we could search multiple computers if we wanted to. Okay, so ultimately, with that feature there, I could maybe take this output and that can be maybe the start of an inventory database that I may be keeping about all my computers. So I could run this and then take the output as objects and do whatever. I mean, I could plug those objects directly into a SQL database if I wanted to, output them as CSV, um, make XML data out of it. Basically, the sky's the limit. Right? So that's the functionality that we're going to be putting in here. Right? So with that said, let me switch over to my little lab environment here, which is not going to be much. I'm literally running on the computer that I'm recording this video on here, and I've got a blank PowerShell session and I've got a blank kind of PowerShell console here. All right. So ultimately, I'm going to start the script with pretty much how I always start just about every script here. So I'm going to put in commandlet binding, right, to make this into or utilize the same features as an advanced function. So if I wanted to use verbose output or debug or things like that. And of course, I'm going to have a parameter block, and that's basically our start. All right. Now, in addition to that, just to start with, I'm going to put some notes up here. So we're going to go ahead and make a block comment. and then everything I put in there is just going to be commented out. So that's going to be some initial notes to start with. Okay. And what I mean by notes to start with are things that I'm actually looking to query here. Okay. Because I normally like to do my queries um, ahead of time here, kind of have an idea of what I'm looking to go get. Okay. So for instance, one of the classes that I want to go query is Win32 underscore operating system. All right. Now, how do I go about connecting to that in the repository? So as I've mentioned, the computers that I'm using in my demo here, they have PowerShell remoting enabled on them. So that's kind of simulating this lab environment that I'm working in. Okay. Um, and they are well, I could simulate some ones that are not on. So let's kind of simulate things are going to be on and accessible, right? Okay, so how do I go and connect to it? So you have the option of using a couple different commandlets here. So get wmy object would be one of them, okay? And that is going to be using the wmy protocol to go query that repository. Okay, so I could use that. The other commandlet, the one I'm actually going to be using here, is get sim instance. Okay, so that by default uses the sim protocol, which is again part of the WS-MAN family. So kind of again, it's kind of you got to remember the families of protocols here. So sim is actually using WS-MAN, right? And then WMI is actually using DCOM, which is actually using RPC. All right, so kind of a bit of fun there. So when we kind of get into the protocol part of it, it's going to be WS-MAN and DCOM are going to be what we're referencing here. All right. So I'm going to use getSimInstance. I'm going to specify the class that I want to look at here. And if you don't want to step kind of outside of where you're at, you could just query the local operating system you're on. So I'm not even going to give this. I mean, I could give this a computer name parameter, but I'm not going to. I'm just going to query my local computer here. So when you kind of hit the output for that, it shows you some of the properties that are present in this object that's returned. Right? Now, you might want more information, and there actually is more information there. So kind of keep in mind, like I've mentioned in past videos here, never trust the output you see by default. There could be more stuff there, right? So I could flesh it out by maybe piping it over to get member and seeing, I mean, look at all of the properties that are actually there, on this sim instance object. Okay, so if I want to see all of those properties and their values, I could send it on over to maybe like select object property star. Okay, so so now we could see for this particular class that there's one instance of it. There's one operating system here. Okay, and that's the object that I'm seeing here. I'm seeing this instance of the Win32 operating system class. All right, so what are some things that I might want to use out of it? So for instance, there is let's see, where is it? Would be helpful sometimes if these were alphabetical order, but alas, they're not always. Okay, so for instance, there's a version number right here. Okay, so literally it's in a property called version. Right, so maybe that's one that I want to grab. Right, so I'm going to put that in my notes here. So out of the operating system class, we're going to want version. Right, so that's the first thing we're going to want. Um, maybe we'll look at let's see. Let's see. What am I hunting for here? Caption, right? That could give me the exact build. So I'm running Windows 10 Enterprise Edition. So maybe we'll grab that. So we'll grab the caption. Let's see what else might be handy here. Let's see. Know what I'm, yeah, OS architecture. So I could tell if I'm working with a 32-bit or a 64-bit operating system. That might be helpful. So maybe we'll grab that, in our little report that we're going to make. Um, and let's say we'll leave it at that. Okay, so grab three things out here. I mean, you could grab more, like the install date. That might be cool. In fact, yeah, let's go ahead and grab that one. What the heck? Okay, we're grabbing four things. All right. So the next class we're going to go query is we're going to want to do, and I'm just going to up arrow to bring up the query from before, and we're going to go query the computer system class. Okay, and again, I'm sending this through select object, property star to see all of the properties. Again, you don't have to fully type this out. You could just type it as select space star, and that will do the same thing here, using the alias and property as a positional parameter. So the star gets passed to it. All right. So what are some things I might want to grab in here? Well, for instance, we might want, let's say, the RAM. All right, so notice total physical memory. So that's how much RAM we might be working with. All right, so let's maybe grab that. So so this was computer system and total physical memory we wanted there. All right. Let's see, we probably want, yeah, like right here. How about like manufacturer and model? So that'll tell me the make and model. So why this is showing up like this is the computer I'm kind of recording this video on, I built myself from parts. So the manufacturer is the actual manufacturer of the motherboard, which is Gigabyte, and it's a Aorus Elite motherboard. All right. So let's grab those two things, manufacturer and model. Okay, so those are two things that I'm going to want. Let's see, and maybe information. Let's see if I can find it here. Yeah, here we go. So number of processors and number of logical processors. Okay, so let's maybe grab those two, and we'll use those. All right, so I really need all the fluff there. Okay, so what that number's telling me, because you're thinking like you got a 24 core processor. No, I actually don't. I have an AMD something. I want to say like maybe like 5900X or something like that. I don't remember. Bought it a couple years ago, and it has 12 cores on it. Okay, so it has 12, but hyper-threading is also enabled on it. So to Windows, it looks like 24 cores because of the hyper-threading. So it's one physical processor, 12 cores on it. All right. Um, and we'll see this. I'll also query out to my laptop, which I have powered on as well, and it has like a different processor, a different core count, and so on. All right. So we'll grab that. And then maybe just to top it off here, just to query one more thing. Let's maybe go query Win32 logical disk. All right. So Win32 logical disk probably should not have done select star on that because it's easier to examine the simpler outputs. Let me just fix that query then. Let's just get that select object property star out of there and look at kind of the simple output here. All right. So what I want is let's say the free space from my C drive, okay, wherever my operating system is installed, right? So that is like something I could filter for, right? So if you notice C colon there and the free space, right? So we could potentially go ahead and grab that, right? So that was 132 logical disk. Um, so I'll just call that, let's see here. so logical disk, and I wanted free space from C colon, right? And C colon, that was device ID. All right, so the device ID property C colon, there we go. Okay. Now, just because I've kind of done this a bit before, you could also like, well, what if your operating system is not your C drive? You know, maybe C is like your small recovery partition or something like that, and your OS is really on your D drive. Windows is really on your D drive. Well, if you go back and look at Win32 operating system, that will actually tell you what your system drive is. There is a property for that. Okay, so that might be helpful right there, just to get that C colon, because then that could again be the filter for this. All right, so that might be something we could do as well. So let's maybe throw that in there. So that was in operating system as what? Let's go find it again. As system drive. All right. So $OS dot system drive. Let's say something like that. So again, this doesn't have to look nice. These are just notes for myself, so that I know what I'm actually after, right? So we're going logical disk, computer system, operating system, and the properties that I want to grab out of each of those. So I have it nice and listed out. Okay, so I have a plan for what I want. Okay, so ultimately I'm going to delete these nodes once I'm done, but the plan is there. Okay, so always good to have a plan, as they say. Okay, so let's put some of the structure of the script together here. So again, I'm not going to write it soup to nuts to start off here. I'm going to build it in pieces and make sure I test each piece. So that way I know things are running good, and then I can proceed on. Okay. So we'll first of all start in our parameter block. Well, we'll put in a computer name parameter. So I know that's going to be in string format, so I'll just cast it as string. And I'll call it computer name to stay consistent with other things in PowerShell. So if you have a commandlet and that commandlet reaches out to another computer, its parameter that does it is always computer name. So I kind of will name my script the same thing, because ultimately I might want to make a function or a module out of this. So, might as well make it consistent with what other Microsoft supplied commandlets and functions behave. All right. So that's in a separate build a script video. I do show how to take some standalone scripts, package them up in a single file, make a module out of that file, and then your standalone scripts can now become functions that look just like PowerShell commandlets when running them in a PowerShell console. So check out that video if you wanted to see how to go ahead and construct a module of all of these standalone scripts you might have developed. Okay. So I'm running this uh, parameter of computer name. I'm ultimately going to want it to accept multiple values, right? So I'm going to come in here and I'm going to put in the just the two just the two brackets nestled next to each other, right next to the data type. So this is how you actually see it documented if you look in PowerShell help, if a command that will accept multiple values on a parameter, right? So that is there. I apologize if you hear some background noise. My dog is really laying on the floor in my office and he's snoozing and he's starting to snore. So he's having a good old time. He's in his post-breakfast nap phase right now. So I'm recording this at in the morning for where I'm at. Okay, so now let's come down here and let's put some structure together. All right. So what I'm going to do is, since I'm going to be doing a lot of different queries to a remote computer, I'm going to make a session out of this. So when you're using the sim commandlets, get sim instance, you can actually make a session ahead of time for them, and specify what protocol you actually want to use for that session. So the first command that we're going to use for this is new sim session option. And with that, I could specify what protocol I want to use. And it accepts, as you can see, it has a default, default values to it, or I should say not default values, accepted values to it of DCOM and WSMan. So if you're doing DCOM, you're really using WMI, right? And if you're doing WSMan, that's really SIM, right? How it's kind of referred to here. So that is ultimately going to be um, another parameter for me, right? So protocol, I'll put in there of just a variable dollar protocol, right? So I can kind of tell what I want to use, and then go back up into my parameter block here, and we're going to go add another parameter in. So that one's also going to be string, and we'll say it's dollar protocol. And what might be handy, since the values being fed into here is it only accepted WSMan or DCOM, I should make like a validate set for it. So that means that only one of two values could be supplied. So I can type validate set, and then open close parenthesis, and then close that element. And then in here, in quotes, I can put what my acceptable values would be. Okay, something like that. Okay, so now there is a parameter for what protocol to use, and then that's going to be fed down to here. Okay? And since I don't necessarily think the user is going to supply this every time, I'll set it to a default value, okay, of WSMan. All right? So now, why am I like capitalizing some things here and making these lower cases over here? So when I make the parameter name in your parameter block, when I capitalize things, that's how they're presented when, let's say, someone runs the script and they maybe tab complete the parameter. Or they tab complete on, when you have validate set, you could actually tab complete the values. So I want them to look nice when they're tab completed. But for the rest of the logic in the script, it doesn't matter if it's uppercase or lowercase. Like notice here, it's all lowercase, all lowercase. But when they're presented to the user running the script, I want them to look nice. Right? Look, gives you more polish, if you will. Right? So then we're going to take this value and we're going to have to save it. So I'll save it maybe in option, right? Which is a variable that I'm creating on the fly here. Okay, so then we'll come in and we'll go make our session, which again, I'm going to save in a variable as well. So we're going to reach out to a computer by doing new sim session. The computer would be dollar computer name. And the session option, that's why I made that option earlier, because that'll tell it what protocol to use. And we'll go from there. All right, so that now has a session created. So new sim session, computer name, computer, session option, option. All right, so that gets that. Then we're going to go do our queries for the information that we're going to want. So we're going to do get sim instance. Instead of specifying the computer I want to connect to, I'm going to utilize a session if I wanted to do that. So in this case, it's sim session and dollar session. Okay, so you could think of a sim session. It's very similar to PowerShell remoting, where you can make a remoting session as well. I guess I could have done that as well, but okay. So the class, the first class we're going to query is Win32 operating system. All right. Now, just to make a note here, if you wanted to look at other classes that were out there, literally there's thousands of them that are in the repository. I highly recommend a tool called WMI Explorer that you could go download from GitHub. Okay, so if you wanted to do that, so in fact, let me just I'll show you where to go. Let me bring a browser window in here, and if I search WMI Explorer, you want the one from GitHub right here. So this one right here. So I open that up, and then I can go. There's a big old download link right here. I open that up, and then the zip to download is like right here. So you extract the zip file out and then you just run it. It's a self-running executable, nothing really to install. And that can use, it uses the WMI protocol to go query your repository, but it does it in a graphical way. So it's kind of almost like a reg edit if you're comparing it to the registry, which could be nice to explore the repository. All right. So if you want to see what other classes and instances and namespaces are out there, that's a good graphical tool to go kind of experiment with. Okay, so anyway, so back to here. And make sure you get the GitHub one. There's other companies that make a tool called WMI Explorer and they charge for it. So I want you to grab the GitHub one because that's the one that's free. All right. So I'm all about I'm all about the free tools. I don't want to see anybody spend any money on a lot of this stuff because it's just not necessary. All right. So back here. So we're going to do that. We're going to, let's see here. So I'm just going to dupe this line like another 2 times and query the other ones that I want. So I wanted computer system and I wanted a logical disk. Right, like so. Okay, and then lastly here, that got me the information. So now what I'm going to do is I'm going to take the sim session that was created and get rid of it. Don't want that thing hanging open forever. It'll eventually time out. It is using kind of like PowerShell remoting session, so it will eventually time out. But still, you opened it up, makes sense to then close it back down. Just being a good citizen on the network, if you will. All right. So that could literally be the beginning part of the script here. Okay, so that's pretty much as I like to get into to start off, right? So let me kind of collapse my notes there. It's a neat thing about a block comment as well is you can kind of collapse and expand it to hide it or see it. So let me collapse it here and let me go ahead and save this. Let's put it. Let's see, let's put it in my demo folder here, and we'll just call this, um, how about PC query? All right, just to give it a name. All right, and then let's see if it actually works. As we have right now, we're not done with it, but I want to see if what I have right now like works. Okay, so I'm already in the demo folder here. We can see there's PC query. So let's go ahead and run that. So PC query for computer name. The name of this computer is Hunter01. And it looks like we got some results. Okay, so here's the result for operating system, for the Win32 operating system class. Here's Win32 computer system, and here's the logical disk stuff, Win32 logical disk. Okay, so that's cool. So that got us some stuff here, okay, which is nice. Now the output though looks like looks like kind of like a pile of garbage, if you will, right? So what I want to do is I want to take, these different objects. So this was its own object, this was its own object, this was a whole pile of objects here. And I want to make a single object as output with the properties that I mentioned here. Okay, so I want some stuff from operating system, I want some stuff from computer system, and I want some stuff from logical disk. Okay, so that's what I'm after. Now, the first thing, if you want pieces of something, you need to take the original query that produced it and capture it in a variable. So I'll do $OS equals, because that's the operating system one, $CS equals, that's computer system, and then maybe $disks, because that's the logical disk one. That's ultimately going to be one, so I'll just do $disk. How about that? And so I go ahead and I save that. And now when I run the script, it's not going to return anything, right? Because all of the output was captured in variables, but I didn't do anything with those variables. And if for anybody who's ever messed around with PowerShell would know, after you're finished running a query, after you're finished running a script, the variables that were defined in the script, they are purged from memory once the script finishes running. So if I ask it $OS, it has no idea what that is, right? Or $CS. So those are variables that were defined in the script, but the script is finished running, so they're not a part of this console. So there is a way to set a variable in a script that will live when the script finishes running. You have to set it using the set variable commandlet and you have to tell it to set it in the global scope, which is the scope of the PowerShell session that you're running the script in. All right. Okay, so let's see here. So we captured the information, and now we want to do something with the output. Okay, using the notes that I have up here. Okay, for what information that I want. Okay, so in fact, I'm actually going to take this block comment since I'm going to be working on the bottom of the script, and I'm going to just move it down so that way the notes are like right there and easy for me to see in reference. Okay, so what I'm going to do is I'm actually going to build an object out of this. So the first thing is we're going to build a property table. So I'm going to call this $props. And we're going to set it to a property table is going to be a hash table. So you start off with an at and an opening, and then ultimately you're going to close it. Okay. So a hash table basically has a bunch of name value pairs in it. So how it works when you're making an object is this is going to represent the name is going to be the name of the property and the value is going to be the data that goes in that property. So this works great for a property table. Now, it doesn't all have to be in like one big line here. You could actually split this up on multiple lines and it makes the hash table look a little more orderly, a little cleaner, if you will. So I'll start off with the opening and then the closing of the hash table I'll just leave like down there. All right. So the first thing we're going to put in here is we want the computer name. All right. So I'm going to make it a property called computer name. Guys, that's literally the property. And I want to grab the value from the computer name variable. All right. So that has that in it. Then next, so we're going to do a carriage return to there. And then I'm just going to do tabs to kind of line the next property up so it looks kind of neat here. So let's throw in maybe version. All right, so version. And where are we grabbing the data for that? So that's in the $OS variable. Okay, so that was operating system and in a property called version. All right. Then next, we're going to do caption. So that had like Windows 10 Enterprise Edition, something like that. Caption doesn't sound nice though, so my property I think I'll call edition. Oops, helps if I spell it right. So edition. So that's again $OS out of that object, and we want the caption. Right? Let's see. So what else? We wanted OS architecture. So I don't want it to be called that though, so I'll just call my property, if I could remember how to spell architecture. There we go. I think that's spelled right. If it's not, I don't know, laugh at me, I guess. No real spell check here. So $OS.OS architecture. All right. And then we're adding one more from operating system. We're doing install date. So maybe I don't know, what do I want to call that? For lack of anything else, we'll just call it install date to start with, and that's $os.install date. Okay, so that covers the first part here of the object that I'm creating. So it's going to have the computer name, which is already in a variable. Okay, so we got that from the parameter when the script was run. The version, the edition, the architecture, and the install date. So those are all coming from the object that we got from this query right here. Okay, and these are all just referencing the properties that we're grabbing out of that object. Okay, and we're putting them in properties that we're creating onto this side. All right, so sometimes I went with the same property, that's fine, but sometimes I made my own property instead. Okay, you're making your own object, so you could do that. Okay, so the next one is going to be data from computer system right here. Okay, so we already kind of sketched out what properties we wanted. Okay, so we're going to go ahead and put those in. So I wanted, let's say we wanted manufacturer, which was in $CS dot manufacturer. We wanted model, which was in $CS dot model, and I'm leaving them named that way, model and manufacturer. That's probably fine. Let's see. We wanted total physical memory, okay, which I'm not going to call my property that. How about I just call my property RAM? Okay. I remember I was teaching a PowerShell class a couple weeks ago, and yeah, my students all thought total physical memory meant the free space on the hard drive. Okay, not the free space, the total space on the hard drive, and it's trying like no, it's RAM. There's a different value for the space of the hard drive. So in this case, $CS dot what was it? Total physical memory. Okay. Sometimes the IntelliSense and ISE is nice. It can help you out when you don't want to type all of that out. Okay, so yeah, these next two ones are kind of big as well here. So we wanted, how about I make a value called proc count, and that would be $CS dot number of processors, and then maybe core count. And that could be out of that same one. And in this case, we're going to do number of logical processors. Okay, so those two values right there. All right. So as I go through construct this table, see why I took notes ahead of time. It then makes it easier to figure out the stuff you're going to want to put in there. All right. So the last one, we wanted free space, and this was going to be free space on the C drive. So we're going to fix this one up. So right now, I'll just say, let's just grab $disk dot free space. Oop, free space. All right, so let's do that. So that now finishes my property table. And since free space was the last property, I'll put the closing element there. So this is basically now my hash table. Right? So now we're going to make an object from that hash table. So we're going to do new object, uh, type name, PS object, and property $props. All right, so making that property table. Okay, at this point, I don't need this set of notes right here, so I'm just going to get rid of that. I still have the notes up here in case I need to consult them, but for the most part, I think we're good with that. And so that will now output an object, right? So let's see if that actually works. Okay, so just looking here, make sure I didn't typo anything. I guess I'll find out in a minute. Okay, so let's bring it up here and let's try that run the script again, pointing it at the same computer. And we look at the output, and it looks like we're close, right? So the first thing you notice, and this is when I was first learning this back in the day, something that always frustrated me was, hey, I go ahead and I make this property table, and then when it gets displayed as output on the screen from the pipeline, there's no correct order to it. So notice how computer name is like over here. It's not first. Core count is at the bottom. It's not in the order that I listed it out in. Okay, so that might be a pain. Right. So what's happening with that is when you have a hash table and you don't tell PowerShell otherwise, it feels perfectly entitled to display the properties in whatever order it feels like. All right. So it feels like, hey, no problem, we're going to go do that. So how you counteract that is you make an ordered hash table. So you literally put your cursor right in front of the @ symbol, do a bracket, type the word ordered, and then close the bracket. So you're kind of casting this hash table as an ordered hash table is what you're doing. Okay, so notice now if I go run the query, you can see it's the exact oh, I didn't save the script. I'm like, it's the exact order. Like, no, it's not. It helps if you save your script. Okay, let's try that again. So now if we look at it, you can tell it's the exact order that things were listed in the hash table. So that's an interesting thing to know because you might want to arrange your properties, especially if there's a lot of them in alphabetical order. Okay, so maybe leave computer name at front, but maybe everything else you might want to rearrange so that it's in alphabetical order, right? So that way, when someone's examining your output, it's like, easier to work with, right? So that should be there. Version should go down to the bottom. Um, let's see, get rid of architecture because I listed that one twice. Let's say, what would come next? This is like, right? It's kind of like, hey, how well do I know my alphabet? E, free space would come next, right? I, M, R, oh, this one would need to go right here. And I think we got it. Okay. So now, ACEFIMAMOPRRV. There we go, alphabetical order. So now, when I run this, and we see all of the properties, let's move this back over here. We see all of the properties. They're now listed in alphabetical order, except for computer name. I wanted computer name to be like the first one. All right. So that's pretty cool. So that's why if you look at the output for some commandlets, sometimes their properties are in alphabetical order when you display them as a list, and sometimes they're not. It's just how it was done in the code of that commandlet when they're putting together their property table. So that's, if you want to do it, cool. Adds a little bit of, I don't know, nicety to it. Not necessarily, but, could be fun. Okay, so that gets structure set up here for a single computer to basically run. All right, so a single computer, being very specific in what I'm saying here. Okay, so now we made it though so that computer name would accept multiple values, right? So we got our parameter block set up, but what would happen if we fed multiple values in here? So my laptop is Hunter02. Um, and let's see. Ooh. So it's just kind of lumping the values into the same output object, right? So if I actually send this to measure object, I can see it's still just producing one object for output, which that's not cool. So I want a separate object for each computer that's queried, right? So that again could make a difference. Okay, so how are we going to go about doing that? Well, in essence, what needs to happen here is all of this needs to loop for each computer name supplied to $computer name. Okay, and we should already know how to do this. We're going to use a for each construct. Okay, so we're going to use for each, and I need to make up a variable. So maybe I'll do $PC in the variable that could have multiple computer names in it, which is computer name. And then we open up a script block. And then we close the script block down there. And then everything inside of here, we're just going to tab in one position. So that way I know if I kind of follow this vertical line down here, follow my cursor, as I follow it down, for each starts up here, follow it all the way down, and then you got the closing element down there. You could also put a comment here just by throwing a hashtag or a pound sign there and saying, close for each. So that way I'd know that's where it's being closed. This closing belongs to this opening up here. All right. So cool. So that now will loop once for each object that's in computer name. So if I supply two values to computer name, that's going to show up, that this is going to run twice. So now inside of here, every place that I use computer name, I need to use $PC instead. Okay, because that's now the variable that will have a single computer name in it. So that would be right here, $PC. Let's see, $PC right here. And I think that's it. So let's go see. So let's save this, come back into my console. I always execute in a separate console. The ISE and Visual Studio Code, for that matter, they have a tendency to remember variables from the last time you ran things, and I don't like that. So I want something typical that someone will be running the script in, which is a console. So I always run in a separate console. So let's just do one computer to make sure it's rocking with that. Cool. And then let's throw the other computer in here. And there we go. So there's Hunter 01 and there's Hunter 02. So they're both Windows 10 Enterprise. I get free licensing, so I always use Enterprise Edition. However, notice the manufacturing model are different. So that's my ZBook as my laptop, and then this is my desktop. You can see the RAM is different, the core count's different. So the laptop is older. It's a 2014 model ZBook, which just won't break, so I'm still using it. When I bought it, it was a pretty quick laptop at the time because I had to run a lot of Hyper-V stuff on it for doing classes. Nowadays, all the lab environments are hosted online, so all I really needed to do was run like PowerPoint in a browser, and it still is perfectly fine with that. So that's why I still have it. So bought in 2014 and still used in 2022, and it's still running like a champ. Um, so anyway, so Hewlett Packard ZBook 15. So that's the laptop. All right. Now, so I added in support for multiple computers, but I never really cleaned the output here. Okay, so we have a little bit of work to do here, and I apologize. I probably should have done that before I put in the multiple values. But anyway, so let's say I give it a single value here. Notice that free space is horrible. So what's happening here is it's looking at all of the free spaces for all of the drives that you have, right? And that's not what I wanted. Um, I wanted just the operating system drive, whatever drive Windows was installed on. That's what I was looking for. So I need to kind of fix that. So in here, I need to kind of apply a filter here. So getSimInstance does actually have a filter parameter if you want it. All right. So you could do something along those lines. Okay. Now that brings in though kind of its own query language. So that might be something you want to do, but frankly, this is not going to return that many objects coming back. So it might just be easier to take it and send it over to like where object. And let's say where object, I'll use the advanced syntax here, so filter script. And then we'll do a filter based on, let's go back to my notes, based on device ID. Okay, so the object return here, it has all the objects have a device ID property, so that's what I'm going to filter on. And I want to match the value to either the hard-coded C drive, or remember that was also stored in $OS.system drive. So the object returned from here had a property called system drive, which had this value in it as well. So we could do that. So we could go kind of where object, um, and dollar underscore represents the object from the previous command here on this command line. Then we're going to do dot device ID, and then we'll say dash equals, and then what do we want? We wanted dollar $OS dot system drive. All right. So let me do a carriage return after the pipe here just to kind of bring this all onto the line here. So you could do that. So that way, if your code's kind of, wrapping up towards the end of the screen, that could maybe make it a little easier to see. And we'll go ahead and try that out. All right. So let's do a save on that. And we'll go ahead and run. And now we got nothing there. Okay, so something's going on there. So let's see. So let's see. We had that, brought it over. Where object filter script? Oh, it was device ID, not device. Device ID. That was the name of the property. Save that again. So hey, it happens. And notice we have just one free space now. Okay, and that should be the free space of my C drive. So back up to when it was listing them all. Notice that was the first one. So cool. So that fixed that. Okay, now I say that fixed that. Is it really fixed? Well, yes, you have one result, but the result is in bytes. And that may not be the approach I want to go with. All right. That may not be the approach I want to go with because we don't normally judge things in bytes nowadays. Gigabytes is probably the unit we would judge RAM and free space by. Maybe you judge in terabytes, who knows? Um, so what I could do is I could take the free space down here and I can actually do some work with it. So I could take that and convert it to gigabytes by dividing it by 1 GB. So if you're wondering what that is, PowerShell actually knows a few different number units. If you put 1 GB into PowerShell's pipeline, it spits out the number of bytes. 1 MB, 1 KB, right? So it knows how many bytes are in there. So you could take whatever the free space is in bytes, divide it by 1 GB, and that will convert it to gigabytes. And in fact, you may want to put that in your property so you can kind of tell people, hey, that value's in gigabytes. Um, and we'll do the same thing with RAM here. Divide that by 1 GB. All right, and we'll put that RAM GB. So we'll save that. Go ahead and run. And, well, kind of looking better, right? So you notice the free space, it's 431. That's how many gigabytes I have on my C drive. And man, it's a lot of decimal places. Same thing with the RAM. It's a lot of decimal places. So what I could do is I could cast this as an integer. If you're familiar with casting, right? So one way you could do casting is like up in our parameter block here, where we have you have the string and then the variable name after it. So that's saying this variable, whatever is supplied, will be in string format. Another way to do casting, which is what we could do here, is we could use the as operator and specify that I want an integer. Okay, an integer to PowerShell is a whole number. Okay, you could have 32-bit integers or 64-bit integers. I'll just leave it as int. That'll get me a 32-bit integer. You could also have numbers with decimal places that would be either a double or a long data type from .NET. I don't remember. I want to say double, but I could be wrong. Um, but that's not what we want here. We wanted a whole, well, in my case, I want a whole number. So cast it as an integer. There's other ways to do this, but this is frankly the simplest way. So now when I run this, I have 64 gig of RAM and I have 432 gig of hard drive space. All right. So that's that. If you wanted decimal places, you could use the math operator. That has a round method where you could tell it how many decimal places you wanted. So, but I'll just go with a whole number here in this case. All right. Okay, so now that handles multiple objects, right? It does not handle pipeline, so I have not added pipeline support in here. Um, and actually, before I do pipeline, let me, uh, that'd be the best way to explain this here. In your environment, you might not have every computer online when you try to do this query. Like, let's say if I, fed multiple values in. So there's the multiple values for two computers that are online, right? They each come up with their own thing. However, what if I gave it a computer that didn't exist or was offline that day or wasn't in the office that day or whatever? Um, so you see, like, man, that's a bunch of red right there. Okay, so it's not happy with that. Okay, so what could we try to do to fix that? Well, what we could do is kind of like all offer PowerShell an alternative. Like what happens if we try to contact a computer that's not actually there? Well, believe it or not, I still want an object for output. Okay, I still want that. Okay, instead, I'll maybe add another property and call like I don't know online. Okay, where that would return like a true or a false or something like that. Okay, so how can I do that? Well, instead of making PowerShell throw the red error output, you could use what's called the try-catch construct. And the way that it works is whatever code is in a try block, and when I say try block, I mean like a script block, kind of like for each uses a script block right here. So there's the opening of the script block, there's the closing of the script block. So a try script block, the code you put in it, if any of that code produces a terminating error to PowerShell, then the catch block will activate rather than displaying the red error message. So you're kind of offering an alternative. Hey, if any of this stuff errors, run this code instead. So pretty much the this is what's going to error, right? And if that throws an error, none of the rest of this stuff needs to run. Okay, because it's all utilizing the session or the data gathered from that session. So if this throws the error, none of this needs to happen as well. So what I'm going to do is I'm going to take this whole thing and kind of wrap it up inside of a try block. Okay, so I'll literally use the word try, open up a script block, um, And then down here, we will close that script block, and then we'll use catch, and then make another script block for that. All right. And then I'll take all the code that's in here and tab it in one more so that it shows it's inside a try. So again, look at try here. Um, if you kind of, you kind of follow, you can see right there, just follow the line vertically down. There's the closing element right there. All right. So that's kind of an easy way to tell what's in what. So then what do I want to offer as an alternative? So what I'm going to do is I'm going to, first of all, in the try, let's maybe say we're going to make another property in here, and we'll call it online, and we'll equal it to the Boolean value of true. If the computer's there, so it'll return true. And I'm going to take this hash table and I'm going to dupe it down here. All right. And then this time I'm going to do $false. And then we'll put an object together like so. All right, so we'll come in, we'll do, let's see. Oh, I didn't close my hash table. There we go. All right. So basically, if the computer exists, this worked, and I want this hash table to be put together, and then this object with that hash table. If this errors out, then I want this code to run. So I'm going to make a property table just with the computer name and the fact it was offline, and I'll put an object together with that. Okay, so it'll be a more slimmed down object, if you will. All right, so that's what we're going to put together. So let's go ahead and save this, and let's see if this actually works. So let's first of all, again, try it with good data. Make sure everything's working as it should. That's fine. And now let's try it with some crummy data. And let's see. Okay, so it did spit it out. Demo 01 false. And the WinRM client cannot process the request if the authentication scheme. Okay, so we were still showing an error there. So let's see, what can we do to suppress that? So sometimes when you're contacting a computer or multiple computers, PowerShell doesn't always see it as a terminating error. So there's also a whole different type of error message in PowerShell. It's called non-terminating errors. So if I come in here and I set the error action, which is one of the common parameters, if I set that to stop, that'll kind of force that to be a terminating error. And we'll give that a shot there. That should fix that. So it's kind of one of those, like, you don't know to do it ahead of time. You don't know if it's going to throw a terminating error or not. And this time, forcing it to do that suppressed all the error output. The errors are still there. Like if I go look at my $error variable, it is still logged there. All right, so yeah, so you could still find it if you wanted to. So in fact, that's it right there. But if you look at the output, looked pretty clean though. So, and if I kind of bring this over to measure object, it is in fact producing, we supplied 3 computer names to it up front, and it fed 3 objects out for output. All right. Now, it fed them out in list format. Because there's 5 or more properties in the object, and I'm not telling PowerShell what else to do with it. So it will make a list out of that. So that's kind of PowerShell's magic number. If you have an object in the pipeline with 4 properties or less, and PowerShell doesn't have something else telling it what to do, it'll output that as a table. and 5 or more properties, it'll out that as a list, provided you're not telling it what else to do. All right. So how could you tell it what else to do? Well, you could take the output there and just send it to, if I want a table, format table. And then there's my output. Okay. Now, obviously, for the one that didn't exist, it doesn't have any data for those other properties, right? They're all empty. So Hunter 01, Hunter 02, those are populated, right? And so that can give me an idea of, you can have your own filter now. Filter on the online property. So I could do where object property online equals true to see the ones it worked on, or false to see the ones it didn't work on. All right. So you could do something like that. Um, all right. So that seems to be working rather nicely. All right, so let's see. And on that one, we'll throw a note there. That was closing catch. All right. Okay, so let's see. So I don't need my notes up here anymore. Let's get rid of those. And what do I need? What do I need? I have not added pipeline to this yet. Okay, so I haven't gotten to that level. So if I try to pipe a couple computer names in here, I'm going to have a problem. All right. So let's say, let's bring up File Explorer here, C:\demo. Let's say I've got, let's just do a text document. We'll call it names.txt. And then in here, let me find Notepad, bring that over here. Let's do Hunter 01 and Hunter 02. All right. So I've got something in there. So now what I'd like is if I bring those in, like do a get content names.txt and pipe that over to PC query, no love, right? So heck, even if you just have a single name, Hunter 01, and try to pipe that over to the PC query script, again, not going to work with it either. Okay, so in order to have pipeline support come in, I need to add some info onto computer name. So I need to add a parameter element here. Okay, and in that, kind of like how I had a validate set element over here, I'm adding a parameter element over here, and then in the argument list, I'm going to put in, well, first of all, I want to probably make this mandatory, so that way there always has to be a value for computer name. Now, what some people will do is they'll do mandatory equals true, and just by putting the argument into this argument list, so again, the thing between the parentheses here, this is an argument list. So just by supplying the argument, you're setting it to true. So you don't actually need the $true. So I want the mandatory argument and I want value from pipeline argument as well. All right? And that will accept any string objects from the pipeline. Now, if I also want any object coming from the pipeline that has a computer name property, I could put value from pipeline by property name as well. So I have a whole video that's on pipeline parameter binding. So if you don't know what value from pipeline is, that's the by value system that PowerShell uses for pipeline stuff. And value from pipeline by property name is using the by property name system. Okay, so check out that video, PowerShell pipeline parameter binding. Okay, if you want to know how PowerShell treats that, how it passes data from one commandlet to another. Probably worth the time to check out. And then in the script, I need a loop for each value supplied from the pipeline. So it's kind of like a version of for each, except it's specific for pipeline data. And that uses a different word. It uses a construct called process. So that also opens up a script block. And I want that to run, this whole thing to run for each time there's data in the pipeline. All right. So this whole thing needs to loop, okay, needs to loop for each object that's in the pipeline. So I'm going to take that, and I'm going to highlight to tab everything in so that I'm still working on my indents properly. And then down here, I'll put close process. And let me comment that. I like that. All right. So now what does process do? It will loop whatever code's in its script block once for each object that's coming in from the pipeline. Okay, so when you pipe data in, PowerShell feeds it into the parameter that is to receive the pipeline info one at a time. So if there's like 5 objects in the pipeline, it'll feed the first value in a computer name and run the process block. And then once that's finished, it'll feed the next value from the pipeline in a computer name and then rerun the process script block again. Okay? However much code is in the script block. So now let me save this and let's go try piping in a single computer name. Notice that worked. And pipe in multiple computer names and notice that worked as well. So that added pipeline support in for our script to use. Right? So that's pretty much everything I wanted to do in here. So I know this video is kind of getting on here. We're at, what, an hour and 16 minutes so far. Um, but anyway, but this is the finished product, okay, based on what I wanted to do. Has everything that I wanted to do. So I apologize. My screen's a little, well, my screen's big so you guys can see that the text easier, but I can't show, actually, let me zoom it down a bit. I apologize if this is big. Let's zoom it down. So, yep, so there's the finished script from beginning to end. And I will also have a link to it if you wanted to download the finished code as well from my from an Azure storage account that I have. All right. So that's it. For everybody who hung out till the end, I appreciate it. If you got something out of this, if you really liked this video, please consider liking and subscribing. It helps my channel growth ultimately, which can allow me to reach out to more viewers, which will then allow me to make more content if anybody is interested. I'm also always interested in hearing ideas of what might make another good build a script video. So I just kind of come up with my own ideas, but again, I'm not the only one administering a network out there. So there might be some other videos that might be cool, that might make cool videos, other IT script ideas that might make some cool videos. So if you have any, definitely reach out in the comments. Feel free to let me know. And again, I thank everybody for watching and be on the lookout for the next Build a Script series here. So thanks all, and we'll see you in the next video.